Okay, question 11, classic complete the square. So the first thing I'll do, I'll just write my question out actually. So why do we complete the square? Well, it's to help us find the turning point. Every parabola's got one, and this method always works. So first thing you do is take out your common factor, and I'm just going to take out for the first two terms because it makes my life easier. I like to just do that. Now that I've got x squared on its own, I'm able to rewrite this as x plus 3 squared. So all I'm doing there is halving the middle term. So I'm looking for a common factor, and then I'm halving that middle term. And this is now starting to take shape. It's starting to look exactly as it should do. Now, the only thing here is if I was to actually break all that out, right, if I go over here and do x plus 3 multiplied by x plus 3, I'm going to get x squared, 3x, 3x, and 9. So that's going to give me x squared plus xx plus 9. And don't forget there's a 2 around that, so I then need to times that by 2. So that's 12x plus 18. Now, I was quite happy, right? I wanted the 2x squared, and I wanted the 12x. It's over here, isn't it? Right? But I want 23 as my units. And right now, if I broke this out, I would have 23 and this 18. I do not want this 18. And that's why we take away 18. So by doing that, I've balanced out the equation. So the next line will be 2 x squared, oops, not x squared, 2x plus 3 squared plus 5. Now when I break out this bracket, I'll get the 18, I'm going to add the 5 onto it, I get right back to where I started at 23. Okay? So you've taken away this thing that you've made. Right, and this gives me a turning point, FYI. Turning point is equal to negative 3, 5. Change the sign, stays the same. So a nice little 3 marks for that one. Sometimes you find this is tied up with a differential question where you might complete the square and get something like this. Maybe it was, I don't know, 2x take away 3 plus 2 or something like that, right? So your turning point is 3, 2. And if the question will say that's the differential. The differential is equal to your 2x take away 3 squared. Show that it's always strictly increasing or strictly decreasing. So you're saying, okay, well that's x, that's dy by dx. So all my dy by dx's are all positive, aren't they? No matter what value of x I've got, I've always got a positive gradient. And the way you would say that is to say, well, x take away 3 squared, that number has to be greater than or equal to 0. The lowest that will be is 0. The very lowest it will be. Okay. I'll just leave it like that. So that means if I times it by 2, so if I double that, and then add 2, it has to be greater than 0, doesn't it? So the very lowest it could be 0. 2 times 0 is 0, add 2, hence the turning point value is 3, 2. So that's always going to be greater than 0. So just watch those kind of signs, that and that. And then you say, well, therefore, in fact, sorry, and forget one little bit. So therefore, it's always strictly increasing. Which just means it's a positive gradient all the time. And the other thing we do at the side is we say it's greater than 0, for all values of x. All values of x. Just like a little mathematical. Okay, so yeah, you can watch out for that. That sometimes comes up as a kind of add-on to this. So it might get you to maybe differentiate a function, and then show that function is the same as the completed square, and say that function maybe differentiate something and get this, and then it would ask you to complete the square of this, and say if it's increasing or decreasing. So just watch out for that. That's a nice little addition they sometimes do. But yeah, to complete the square, make sure that's nailed. That's three easy marks in the bag.